Hi, Science 20s. Another video for this week. This time we are on page 18 of your workbook, and we're going to look at some non-uniform motion, otherwise known as accelerated motion. And so we learned a little bit about acceleration already. It is when we have an object that is increasing in velocity over time. It could be, you could have something that would be a negative acceleration as well, and that would be an object that's decreasing velocity over time or slowing down. We also learned last time that the formula for acceleration is equal to the change in velocity over the change in time of an object. So it's basically the rate of the change in velocity, and that's what acceleration is. So let's look at a couple graphs here because we're going to be doing some graphing. We're going to be doing a little assignment this week as well. When we look at the first graph here, this would be a position time graph. And you notice when we're looking at an accelerating object, we have a curved line that was built here. So what that means basically is that let's say if we put, we have 1 second, 2 seconds down here. Over the first second, the displacement of the object is going to be that much. And over the second second, the second second, we're going to have actually, so the first second would be that, and the second second would be that much distance covered. So we're getting faster, we're covering more distance every second that goes by. Now, if the acceleration is happening at a regular rate, a velocity time graph is going to actually look like this. So velocity is increasing over time at the same rate. So this is the kind of graph we're going to use for our little lab assignment this week. So we're going to use a velocity time graph. And we see a couple things on this graph. First thing, when you do this experimentally, you're probably not going to get a perfectly straight line. So you're going to actually have to draw what would be called a line of best fit. So if we had some data points, above and below this line, we would draw the line of best fit like that. And then we're going to use that line to help gather some observations and make some conclusions about our data. So we have here, what we've done here is we've selected 2 points on the line that are going to be kind of easy for us to read. They end up right on the edges of the squares on our graph, so we're going to be able to easily read them. So the formula for slope, as we know from last week, is rise over run. Another way we can say that is it is the change in the y value, the delta y, over the delta x. And another way that we saw this was y2 minus y1 over x2 minus x1. Now, your delta y is actually your rise here. So we all know that this is your y-axis, this is your x-axis. So my change in my values on my y-axis is my velocity. So my change in velocity is actually also the change in my y values. And the change in my time is actually also the change in my x values. And what I might do also is I might look at the ordered pairs up for these 2 points. This top point up here would be my x2, my second x value or my highest x value, and y2 or my highest y value. And then down here, this would be x1 value, my lowest x, and then y1, my lowest y value. Okay, so we can use those to calculate. And what we're going to actually see here is it's like if we take delta y over delta x, or we take delta v, which is the same as delta y, over delta t, which is the same as delta x. So we got the change in velocity over the change in time. So when I calculate my slope, actually what I am calculating is the acceleration of my object. Okay, let's flip over to page 19 here, and we'll do a little example. So I have a graph here. I'm going to actually skip over the first 2 questions here. So I have a graph here. I have an object. It's the motion of a motorhome on a steep hill, and the motorhome is finding it difficult to maintain its speed on the hill. And I think you guys can guess what that means. Now, the first question I want to look at here is how long would it be until the speed is 0 kilometers per hour? So the velocity, sometimes we use the words velocity and speed interchangeably, and we already talked about the difference between those two. But to get to 0, which is down here, I would have to predict what's going to happen in the future because I don't have data for that. So I'm going to do what's called extrapolation, and I'm going to make a prediction. So if I were to continue on that line, let's say 16, 17, 18, let's predict about 19 seconds for that. So I would have to extrapolate that, and it's approximate in at this point about 19 seconds to reach 0, and that would be to come to a complete stop. Now we could do some math to figure that out, but we would need to know the acceleration of this object, which we can calculate by finding the slope. So question D is asking us, what is the acceleration between 5 seconds and 10 seconds? So we're going to go 5 and 10 seconds here. And I'm going to make a little point here and a little point here. Okay, and then I'm going to build my little triangle. Okay, so we're looking for a rise over run. And so my rise is this change in the y value right here. So I'm going to have, for this one, I have my y, or sorry, my x1 and my y1. Okay, and over here I have my x2 and my y2. I'll make it a little bit bigger here, and I'm going to change my colors so we can kind of see here. So my x value for 1 is going to be 5, and my y value is over here is 15. So if you guys see how I got that right here, right? So 5 and 15. And then my x2 value is going to be 10. And my y2 value, so that's 10 from there, and my y2 value is actually also going to be 10. So I want to know over those 5 seconds what happened to my y value and what happened to my x value. So my rise or my y value actually went from 15 to 10. So if I took y2 minus y2 minus y1, I'm actually going to get a negative number. So it went down 5. So my to find my slope, it's my delta y over my delta x. My delta y was actually negative 5 meters per second. Okay, so my velocity dropped by 5. Now my run, time is going to go on, and we're not going to be dealing with negative time here. Time is always moving forward. So the difference between 10 seconds and 5 seconds, or my x2 value minus my x1 value, 10 minus 5 is going to be 5. So I'm going to have 5 seconds on the bottom here. And so when we take this, we're going to take negative 5 divided by 5. And we can put that into our calculator. 5 divided by 5 is 1, and a negative divided by a positive is always a negative. So I'm actually going to end up with an answer of negative 1 meters per second, and we know that we have to square that seconds. It's a meter per second per second. That means that every second, this velocity is decreasing by 1 meter per second. Okay, and so that is our acceleration value. So we find the acceleration by finding the slope. Okay, let's look at one more example. So in this graph, we don't have a straight line. We actually have sort of 3 line segments that are all straight lines. So if we want to analyze the motion of this object, we would actually have to do it in those 3 segments. So let's look for one example here. So for question A, what is the acceleration between 0 seconds and 5 seconds? So 0 seconds is here, 5 seconds is here. Okay, my first point is 0, 0. And my second point is going to be 5 seconds and 2 meters per second. So 5 and 2. So to find my slope, okay, delta y over delta x, my change in my y value would be this distance right here. So going from 0 up to 2. So I'm going from 0 to 2. So that's 2 meters per second. Okay, and then here I'm going to take my my x2, which is 5, subtract my x1, which is 0, and I'm going to get 5. So if I take 2 divided by 5, that's going to give me my acceleration. So if I have my calculator out, I'm going to take that. I'm just going to go 2 divided by 5, and that's going to give me 0.4 meters per second. Okay, and it looks like that. Okay, so I want you guys to do the practice that's been assigned to you. You can try the other examples in here. The answer key to the workbook is on Google Classroom. So do this, and then good luck with the lab assignment, and I'll chat with you guys soon.